Everyone, today we are going to continue our discussion of matter in chapter 1. So last time we saw that there are different ways to classify matter. We discussed how matter is made up of atoms, and atoms can make up elements or compounds. And there were different terms that we could use to describe those molecules or elements. Today, we're going to classify matter into several categories based on chemical and physical properties. And we did discuss chemical and physical properties in the last video. So if you did not watch that video, I recommend going back and covering that material. So the first category that we can use to describe matter is pure substances. So pure substances have a constant composition and a fixed set of other physical and chemical properties. So one example is water. And if we had a beaker or a cup, so this is a beaker of pure water, every part of that liquid is water. So it always contains the same proportions of hydrogen and oxygen. And it will freeze at a specific temperature, it will boil at a specific temperature, so nothing varies within that liquid. So it is a pure substance. And remember from last time, we looked at a single molecule of water, and we saw that it has 1 oxygen and 2 hydrogens. Now, another way that we can classify matter is using the term mixtures. Now, if you have a mixture, that means that it can vary in composition and properties. So, for example, if we were to take that same beaker of water and add sugar to it, now we have a mixture. So down below, we have our water and sugar mixture. And you'll notice that we still have these water molecules, and then sugar is just shown as a blue sphere. However, last time we saw that sugar is actually made up of multiple atoms, and sugar is a polyatomic molecule. All right, so let's say that in this mixture we have 2 scoops of sugar. One difference from pure water is sugar water will have a sweet flavor to it. So by adding sugar, we've changed the property of the solution. So properties such as sweetness would be different for each type of sugar-water mixture. So for instance, let's say we only added 1 scoop of sugar to that water, the sweetness would be less. Now, there are different types of mixtures. So for instance, we can have a mixture that is heterogeneous, and the properties of a sample of a heterogeneous mixture depends on the location from which the sample was taken. So if we look down below, we have the example of a pepperoni pizza. And in this pizza, there's crust, there's some cheese, there's pepperonis, and maybe there's some tomato sauce. Now, if we took a slice of this pizza, we would notice that there are different components present in that pizza. So we can see the pepperoni, the cheese, the tomato sauce, the crust, and if we took, let's say, just a piece of crust from that pizza, that would have different properties than if we just took a pepperoni from that pizza. So a heterogeneous mixture it's really easy to tell that you have a mixture of different components. So we can see the different components. Now, the other type of mixture is a homogeneous mixture. And sometimes we just call these mixtures solutions. And the properties of a sample of a homogeneous mixture are the same, regardless of where the sample was obtained from the mixture. So if we look at our water and sugar mixture from before, no matter where we sample from that mixture, so maybe we scoop some out from here, maybe we scoop some out from the bottom of the beaker, all of those samples will be exactly the same. They'll have the same sweetness, they'll have the same properties. Now, in homogeneous mixtures, it's sometimes hard to tell that you have a mixture. If we look at this beaker of liquid, it's hard to tell there's even sugar in there. We would probably have to do some experiments to determine that it is a mixture. So maybe we would need to evaporate or boil off the water. And then we would see that there's sugar left behind, and we would be able to say, oh, this is a mixture. But again, homogeneous mixtures, the different components are not visible. So we cannot see the different components. Now, we talked about pure substances earlier, and there are a couple of different types of pure substances. So let's talk about those two different classifications. The first one is elements. So elements are pure substances, and these are made up of homoatomic molecules. And you might remember from the last video that homoatomic molecules contain atoms of the same kind. So one example we saw last time was copper. And if we were able to zoom in on a copper pipe, we would see that there are a bunch of copper atoms that are just all packed tightly together. We also saw the example of oxygen. And oxygen is a diatomic molecule, but it contains the same type of element or atom, in this case, oxygen atoms. Now off to the left, you can see a periodic table of the elements, and copper is kind of in the middle of that table, and oxygen is in the upper right-hand corner of the table. And we'll talk more about the periodic table later on. The other type of pure substance is compounds. So compounds are pure substances that are made up of heteroatomic molecules. So you might remember from the last video that heteroatomic molecules contain atoms of two or more different kinds. So we saw the example of water last time. So water contains oxygen and hydrogen. So that means that it is a heteroatomic molecule. And then another example would be table salt. So table salt is made up of sodium atoms and chlorine atoms. And if we were able to zoom in on a salt crystal, we would see that there's this really organized crystal lattice, we call it. And every sodium ion, which are these small purple spheres, those are surrounded by chlorine atoms. And every chlorine atom is surrounded by sodium atoms. So eventually we get this alternating pattern of sodium and chlorine atoms. But because we have two different kinds of atoms present in table salt, that means that we have heteroatomic molecules. So just remember that compounds are going to contain atoms of two or more different kinds, whereas elements contained atoms of the same kind. All right, so in your textbook, there's this really nice classification summary where we can see at the top we have all types of matter. And if we wanted to classify a type of matter, first we would ask ourselves, do we have a pure substance or do we have a mixture? Now, again, sometimes it's hard to tell that you have a mixture, so you might have to do some experiments in order to verify that you have a mixture. However, once you determine, let's say, that you have a mixture, then you can try to figure out, do you have a heterogeneous mixture? So can you see the different components present in the mixture? Or do you have a homogeneous mixture, where everything is mixed together so well that you can't see the separate components? Now, if you determine that you have a pure substance, then you want to ask yourself, is it an element? So do I have atoms of the same kind? Or is it a compound? Do I have atoms that are different within this molecule? Now there's some examples given below. So we have the example of copper for an element. And then sugar is a compound. So if we were to zoom in on a single molecule of sugar, we would see that there are many different atoms present and there are different kinds of atoms present. One example of a heterogeneous mixture is oil and water. Now, this is a bit of a strange example because oil and water don't actually mix together. So the pepperoni pizza is probably a better example of a heterogeneous mixture. And then a homogeneous mixture example is a soft drink. So soda contains sugar, it contains artificial flavoring, it contains many different types of molecules that are all mixed together. But when you look at soda itself, it doesn't look like it's a mixture. It just looks like one liquid. So for this homogeneous mixture, we would probably have to try to separate out each component in order to verify that it is in fact a mixture. So let's go over an example. Here we're going to try to determine whether these molecules are, let's go back, a pure substance, a mixture, and then we're going to determine, do we have an element, a compound, a heterogeneous mixture, or a homogeneous mixture. So in this example, on the left we have hydrogen, and you'll notice that there are two hydrogen atoms within one molecule. And then we also have in the middle fluorine, which is another type of atom. And here we have two fluorine atoms within a molecule. And then on the right, we have our product after we've mixed together the hydrogen and fluorine molecules there. And one molecule here contains one hydrogen and one fluorine atom. So you can pause the video and try to determine whether each of these examples are first a pure substance or a mixture. And then once you've narrowed that down, you can try to classify them using those terms on the last slide. Okay, so let's try to determine what each of these different examples are. So first of all, you can probably tell we don't have any mixtures. In the first box on the left, we only have hydrogen molecules. We don't have anything else mixed in there. And that's the same for the other two boxes. We don't have mixtures present. So if we go back to our chart, we're really focused on the pure substance category. So now we just need to narrow down whether we have elements or compounds. Now in the first box, we have two atoms that are the same within our molecule. So this would be classified as a homoatomic molecule, and we said that homoatomic molecules are elements. All right, and sometimes it's a little bit confusing that we have an element that contains two atoms, but that is possible. Now in the middle, we have fluorine, and within that molecule that we circled, there are two fluorine atoms. And because they're the same type of atom, that would be a homoatomic molecule again. So we can classify this as an element. And then in the last box, we have now mixed up all of our atoms, and we have produced something called hydrofluoric acid. And within one of these molecules, we have one hydrogen atom and one fluorine atom. And because we have two different kinds of atoms within that molecule, we would call that a heteroatomic molecule. And we said earlier that heteroatomic molecules are compounds. So everything is a pure substance, but the two examples on the left are elements, and the example on the right is a compound. And then this slide just goes over exactly what we said already, but I will post these slides so that you can go over them on your own time if you would prefer. Okay, so we're going to stop the video there. Next time, we'll start discussing measurements and units. So I do recommend studying this chart that we discussed and just making sure that you understand all of the different definitions. I will see you in the next video.